All right, so the two homework assignments we're looking at before we introduce block, uh, excuse me, before we introduce block expressions or block statements, actually, where we were supposed to, well, that's the add an update statement, first of all, allowing us to change the value of a variable. All right, so let's go ahead and do that relatively quickly. All right, we want to go to our parser first. And we can actually split this out. I'll kind of steal from remember statement. For our update statement. So just like we've done before in our parser, we'll go ahead and create a class. This guy will be a update statement. And an update statement is going to have, well, we'll update it here in a second. It'll have a type. It'll have the variable name that we're updating. Actually, it won't have a type because it's already stored as a type. Update statements are updating variables that already exist in our environment. So it'll have a name and it'll have the value that we're updating it to, which is an expression. So we'll put this as an update. Get rid of the type, and there's the name. ToString. We'll just get rid of the name here and set it equal to the value. Get rid of get type. All right, so now we have a way of representing our update statement. So we'll go back into the parser. Get to it like this. Go to parse statement. All right, and we decided that our update statement, let's go into our syntax real quick, because we've been keeping track of that inside of this guy. We're now adding an update statement. So maybe this guy is called update var name equals expression, something like that. So we're looking for something that begins with the word update. Okay, so if it equals, remember, do one thing. I'm actually going to go ahead and put the update right underneath that. So we'll say else if the parts at bucket 0 dot equals update. All right, so now we want to get past that first piece of it, getting past update. So we want to know where in our string update is, because we need to get to these two pieces to build our update expression. We need var name out of this, and we need expression out of this. So we'll go ahead and take the substring up to here. Then we'll split it on the equal sign. So let's call this guys. Well, it's really the rest of it. We'll just do it this way. So we'll say string temp is equal to s dot substring from update dot length and then we can trim that, just say in case. So this should be everything from well, actually we are going to trim it because we'll get rid of that space. So this will be up everything after update. Then we'll go ahead and split that. We'll split it on the equal sign. So that'll give our left and right portions. So by splitting it on the equal side, bucket 0 is the variable name. Bucket 1 is our expression. So we now have our two pieces. So we'll say string var name is equal to temp parts at bucket 0, string, call this expression string. I know we don't need to create variables for all these, but we're going to do it anyways. Is going to be equal to temp parts at bucket 1. All right, so now when we go to build an update statement, we need to pass this guy a string and an expression. So how do I get the expression out of the other guy? I call parse expression. So I'll go ahead and say expression. The expression is equal to this dot. Actually, it's not this dot, because this is a parser dot parse expression, and I'll pass it the expression string. All right, so now we don't need to change anything inside of parse expression for this guy, because update, the right-hand side is going to be some kind of expression, probably a literal expression. In this case, could be a math expression, whatever it is. We've already written our interpreter for that guy. All right, so we'll go ahead and get the expression. Now we can go ahead and build our, I see how some of these other ones we did it all in line. So this one I'm being a little bit more explicit with. It's fine. So we'll go ahead and now we're going to build a update. So I'm going to treat this guy, let's treat it like a parse remember.
I have a question.
Go ahead.
Is that, can you scroll down?
So where I just was?
Yeah.
Where was that parse expression? No, I'm parse statement.
So is the string temp parts where we split it, is that an array, the temp parts?
Yeah, this is a string array. This part here
Because
tells you that it's an array.
because it has two different like variable name and expression in it.
Correct. That's what split does. Split gives us an array.
Oh yeah, okay.
So this function right here, temp.split, the split function says I'll split your string up on equal signs and give you that as a string array of parts.
It does always.
Yeah, that's what split does.
Okay.
Split always returns a string array.
Okay.
All right, so we'll go to parse expression here. And parse expression takes in a expression string and it goes ahead and does either the do math or the test or whatever kind of expression it is, and it'll spit out for me an expression. So that guy already does what we needed to do. So I have my expression string, and now I go ahead and get my expression. So now I need to go ahead and call, ultimately, what's this guy returning? He's returning a statement. In this particular case, he's going to return a update statement. So I went up to parse remember, and I'm going to model parse update after this guy. He's going to return an update statement. And it's going to be called parse update. He's going to take in the name, and he's going to take in the expression. And he's going to go ahead and build an update statement. This guy's going to be a new update statement. Passing it the name and the value expression, and then it'll return that update statement. So I want to call parse update on those pieces. So I'm going to return, because I'm inside of parse statement, which returns one of my statement types. I'm going to return parser.parse update. I'm going to pass it my var name. And I'm going to pass it my the expression. Okay, those are the two pieces needed to create a update statement, and that will return that from this guy. All right, so let's go test to make sure our update statement is doing what we want it to do. I'm going to get rid of this while loop here for a second. So we'll update e is equal to 0 there at the end. I'll go ahead and display what's the result of my parser initially. String index out of bounds. Parser 223. Is that from? Where's my spider? So the last thing should have been question. Oh, hold on. Well, it should be okay there. before I forget, I need to go to my update statement here. Okay, I did already update it to the update statement. So my last thing was remember C. Oh no, that was my question statement, which should have been the last thing in there. All right, so it did die on my update. So what was the error message? String index out of bounds. So it didn't like me looking at bucket 0 right here. For parse expression. Oh, I think I have bad syntax written. Could I just say? I can just say that, right? Update E is equal to 0. Yeah, we're treating those guys as expressions. It's a literal expression. It's getting past where we wanted it to be. Because we're inside a parse expression, we're looking at what kind of expression is it? Is it a do math expression? No. Is it a test expression? No. Else, is it a digit? Was it array index out of bounds? Is that the actual string index out of bounds on 0? So I'll go ahead and just put a break here. Let's just see what the parts looks like, and that should give us what our issue is. It's probably a trim or an extra space or something like that. Or I'm not splitting on the equal sign correctly is what it sort of looked like to me. All right, I'm going to, how many lines of code did I have? I had, you know what, let's actually do our breakpoint inside of update. That'll get us far enough down. So I'll get rid of this breakpoint. And then inside of parser, I'll put a break right here. That'll get us into our update statement right away. All right, then let me get it so I can see my stuff over here. Okay, so this is what the parts looks like, update E. So after I go to temp, this should get rid of the update. So let's step over this guy. So now I have temp. Temp is E is equal to 0. That's what it should be. Everything but the update. Now let's get our var name. So var name is just E. Then let's get our expression string, and that should be the 0 piece. Okay. Where's my expression string? Well, here I can just go into this. So I'm inside of, oh no, the error was it ran out of, it tried to read another line. Oh, no, we're still inside of it trying to do parse list of statements, add parse statement. It's still dead in there. So let me get back to where we just were. Okay, we're good there. We're good there. We got our var name. It's our expression string. So there's our expression string. It has a little space before it, which I think is the issue. So we got to do a dot trim here. All right, there we go. Just an extra little space in there we forgot to trim. So now we have an update expression. E is equal to, it's an expression with a literal expression of 0. That's fine. So now that guy is parsing the way it should be parsing. All right, then the second half of this, let me just stop all this. And what was that not make it go away? There. So now we'll go over to our interpreter.
In the return type of in the remember statement,
Yeah.
so like we in the return type we pass like var
Well,
name.
it's not a return type.
I
It's
mean,
setting what the type of that value is. We're not using that yet, but it's setting it.
so we are passing the var name and the expression. So the expression, it could be value, since we have two parameters in the update statement. So why we have the expression?
Because the thing that's on the right-hand side here could be anything. It could be a do math 2 + 3. This guy here is an expression. It's not always a literal number. Well, even a literal expression is an expression. So this guy right here is some kind of expression. That's what we're setting E equal to when we're updating it. The value of an expression. Is that what you're asking?
Yeah, so in the remember statement, under the expression,
In here?
on that side, where we are in the parser,
Okay.
the last yeah, in the update,
Okay.
yeah, there is a return parser dot parse update,
Yeah.
and then there is a var name and the expression. So I was confused there, like why is the
Expression is right
expression?
here. This guy is the right-hand side. I'm building a parse update, which is an update statement. An update statement requires two pieces: a variable name as a string and an expression as an expression. That's what it requires to build an update, a parse update. To build an update statement, I need two pieces of information: a string and an expression. I get that expression right here by calling parse expression on the expression string. That gives me an actual expression. And then I pass that expression into parse update, because parse update here takes in a string and an expression, and it builds for me a new update statement using that string and that expression. That's what goes into an update statement. The right-hand side of the equal sign is an expression, some kind of expression, which will be the new value of that variable in the environment. Does that make sense?
Yeah.
All right, so let's get over to now the interpreter side of this. So my interpreter my spider interpreter here. And we'll start off by looking at interpret. Interpret's going to go through all my statements and it's going to call interpret statement, which is this guy right here. Interpret statement is asking, is it a remember statement? If not, is it a question statement? So I'm going to go ahead and I'm going to add a new else if in here. S is an instance of a update statement. If that's the kind of animal I'm looking at as an update statement, I want to build and interpret update statement. So we'll model this guy after our, my eyes are not seeing great this morning. We'll model this after remember statement. So under interpret remember, I'll just go ahead and steal this guy and we will call this guy a interpret update statement, and he's going to take in an update statement as a parameter. All right, so we need to go ahead and resolve the value of the right hand side. So that's going to be our update statement, get value expression. So that's going to get the value expression from the parsed update statement. And then we'll store that inside of our expression. And then we'll get the answer of that guy from our get expression value of that value expression. So that will actually resolve the right-hand side of the update expression to its new value. And that new value will be some integer. It might come from a literal. It might have come from a do math inside of a do math, inside of a do math, whatever. It's going to come from something, everything on the right-hand side. All right. But now, instead of us just adding a variable, so this is the what do we do with this guy piece? Okay. So instead of adding a variable, we need to update something in our environment. So we're going to go back to our environment here. We haven't visited in a while, our variable environment. And I'll just go to add variable for a moment. So add variable is going to go through and it's just going to add to my variables, which is the list of name value pairs, right? My name value pair array list is called the variables. I now want to have a function called update variable. So I'll say public void update variable. This guy will take in a string name and an int value. And we want to go through and find the variable inside of my array list whose name is equal to name. Now we're not dealing with scopes yet, so we're just going to find the first one. So we're going to say for, what do I call it? Name value pair. Name value pair MVP in this dot the variables. If MVP dot get name dot equals name. If I'm looking at the variable that I want to look at, I want to set that guy's value to something else. MVP, do we have a set value? Yes. And the value I'm going to set it to is value. So if I found the variable name that I'm looking for, I will set its value to this new value that was passed in. And then I'll just go ahead and hit return. I'm done. I found my variable. I updated its value. I'm done. All right. So that's what update variable will do. So now I go back to my spider interpreter. Go back to update, interpret update. So rather than add variable here, I'm going to call update the variable. And I'm going to say get name for the variable name. And my value that I'm updating it to will be answer. And then I'll, just for the sake of, we'll say updated get name to answer in the variable environment. Just update our commentary a little bit there. So that's my interpret update statement. And that guy gets called from within interpret statement. So now what I'll do is I'll call spider interpreter dot interpret update statement, and I'll pass this guy the statement as a update statement S. So if I know I'm looking at an update statement, I'll go ahead and call interpret update statement, passing it S as an update statement. And that'll go ahead and interpret it for me. Come back out to driver. Let's look at what we should be seeing. E started off as the answer to some crazy thing. In fact, let me just do this. Just want to see what E's value was. Was it like a 2? Where is my? Oh, is it showing it down here? Oh, there it is. I like seeing it up here. All right, so E was a 2. So now I can go back into this guy. And now it should turn to a 0 in the end. So I updated E is equal to 0 in the variable environment, but this guy is still a 2. The results should have shown the update. Let's make sure I am in fact calling that guy. So my variable environment. I should be getting right into here. Debug that real quick. Oh, that's in my interpreter. I need to turn this breakpoint off. Just run it again. Oh, I'm never getting into that. That would explain something. Okay. So in my interpreter, I should be getting into, let's just do interpret. Statement right here. I should be getting into that right there. My last one should be an instance of update statement. Okay, here's my update variable. And for update variable, I'm looking at name is E, the value is 0.
E has a space.
Oh, it does have a space. Thank you. So that actually would have had a space from where I put it in my parser. Let's fix that in the parser. So when I built a parser, when I parse update, that's my value expression. So then let's go down to parse statement where I do that. Oh, it still has the space there inside of my expression. That's fine. We'll do it in the interpreter then.
You can do at line 259. Var name equals to,
It was the variable name that had the space.
yeah. Because you split
Yeah,
it by
Right,
equal sign.
right,
So
right.
there's a
And now our E is 0. It was just never finding our variable named E space from before. So now we're updating our environment reasonably. Okay, so now we have ability to update the environment. The next step is, and here I'll go ahead and actually push that so you have, that was, what homework assignment number was that?
the,
Eighth number.
it is a while loop.
No. What homework assignment number was update? So I can,
Eight.
I'm gonna-
Eight. Eight.
8?
Yeah.
Yes.
Okay. That's right. So support for update statement homework number 8. Just so you have a kind of a flag of when that was complete. All right, so now we do the while loop, but this is a very basic while loop that can only handle update statements, because right now we only know how to have a single statement associated with a loop, right? So we can create our syntax for our while loop. So we'll go in here, not there. Go ahead, let me hide this. Where's my input spider? All right, so now I'm going to do something like while, and we're going to do some test is true. So we're going to say while E greater than 0, and this is actually a test, right? So while test E greater than 0, we want to do something. And we'll go ahead and say update E to be equal to, do math, E minus 1. Something like that. So while E is greater than 0, update E to be whatever it currently is minus 1. That's what we want to be able to support here. Okay. So to support this guy, we're going to have to build out our while loop, and I'm actually going to steal this for a second. We'll go ahead and add it to our README. So we have a while statement now. Now notice that this is a little different than what we've seen in other languages leading up to this point, that our while statement is actually going to end in a semicolon, which is legal in Java. All statements can end in a semicolon, even though we typically don't put a statement after a closing curly brace or put a semicolon after a closing curly brace. They've made that to be an exception for the syntax, but we're going to leave it in ours just to keep things relatively simple for us. All right, so this is going to be update. We're going to call this guy a Boolean. Oh. Call this guy a Boolean expression. Actually, let's call it a test expression. That's what we've called it. So some test expression, then we'll do, and this guy will be some kind of statement. Any kind of statement. Now, right now, the only statements, well, it could be any kind of statement, but ultimately, if we want this guy not to be an infinite loop, this statement has to eventually become false. So our only option right now for this statement is going to be an update statement, because we need something to change whatever variable we're testing against here. Okay, so this is what it's going to look like, but we're only going to be able to make it work for update statements currently. And then we're going to talk about block statements, and that'll be the next homework assignment. Okay, so while test expression do statement. So just like before, we'll start off in our parser. Let's actually go ahead and let's create a we'll steal from remember statement, I guess. You know, at some point, this is just going to be, we're changing too much, but we'll leave it in there. Okay, so we're going to go ahead and create a while statement inside of our parser. So new class while statement. And this guy will extend statement. A while statement is going to have a test expression. So we're testing something, and then it's going to have the this will be a statement. This will be the statement to execute when test is true. I can't name it with dashes like that. Let's go something like that. All right, and this guy's then going to take in an expression, test expression. And it'll take in a statement to execute. All right, so constructor for a while statement is built using a test expression and a statement to execute. This will be a while statement. this dot test expression is equal to test expression. This dot statement to execute is equal to statement to execute. So we'll set those guys up for our toString. This guy is going to have a statement. Well, it'll have a test expression, this guy. I'll call that guy's toString. And then it'll have a statement to execute. And I like putting this dot in front of these, even though we'll put his toString in there. All right, so that's what toString for our while loop will look like. And I'll go ahead and just redo the getters and setters. So we'll do source, generate getters and setters. And we're going to give ourselves a get for both the test and the execute statement. All right, so now we have an object to represent our while loop. So now we'll go into our parser. Go into parse statement. I'll add my else if here, else if the parts at bucket 0 dot equals while, if that's the kind of animal I'm looking at, then I need to start getting the individual pieces of that. So my while loop looks like this. Just bring that into my parser. Comment. So that's what this guy looks like. So I'm going to go ahead and get everything after the while first, like we've been doing. So we'll say string temp is equal to s dot substring, and I'm going to go from while, sorry, dot length, and then we'll say dot trim. So that should get me from here to here. Actually, the statement's already been ripped, so it's there to there. That's what I currently have. So now I can get my two pieces by splitting on the do. String temp, string array. So just like we did in our update, temp parts is equal to temp dot split, but I'm splitting on the word do instead of an equal sign. All right, so I have my temp parts. Then I'm going to get my two pieces from this. The left-hand side is some expression. So we'll say string test expression is equal to temp parts at bucket 0 dot trim. I'm going to call this test expression string. And then we'll have string execute statement string is equal to temp parts at bucket 1 dot trim. So now I have this guy as a string and I have this guy as a string. And what do I do to something that is an expression? I call parse expression on it. I'll say expression, and actually I can assume it's going to be a test expression, but let me just keep it generic right now. So I say expression. We'll call this guy test expression. You know what? I'm going to call it a test expression here. That is what it is. What I mean by that is this can be any kind of statement, but the left-hand side has to be a test expression. That's the kind of animal that goes there. It can't just be any sort of expression. It has to be a test expression. So we're going to have a test expression coming out of there. I'll store it inside of test expression. And how do I get an expression? I call parser dot parse expression, and I pass it my expression string. And my expression string is called test expression string. And I know it's ultimately going to give me a test expression. Now, for right now, I guess I can say expression and then this guy's happy, even though I know he's going to come out as a test expression. Otherwise, I could have typecasted it here, but I want to keep typecasting all in one place, just so I'm not doing little quick fixes all over the interpreter. You know, so that you kind of want to have this stuff organized probably better than we have. We're just kind of adding features one after another, and our organization kind of limits our update parser, then update interpreter. We're creating our objects for things, but we're being a little bit, I guess, unorganized in that, you know, we're just kind of randomly trimming things here and there, and where we do typecasting is a little bit, you know, like, oh, I know this is going to be a test expression, so I could make this guy a test expression right here, but instead I'm just going to get him as an expression, and then once we get him to the place where he has to be a test expression, that's where I'll do the typecasting. So we probably could have been a little bit more organized when it came to when do we trim and that kind of stuff, maybe even having a single like splitter class that takes stuff in and then gives us stuff already trimmed. That maybe would have made more sense, but this is fine. I mean, for what the model we're creating, this will suffice. All right, so we'll go ahead and get our test expression. Where does that come from? It comes from calling parse expression on our test expression string. And then we'll also go ahead and get our statement execute. Steal this so I don't have to spell it. Execute statement is going to be equal to parser dot parse statement. And this guy will take execute statement string. All right, so that's how we get our two pieces from this. And then ultimately, what do? We call parse while. And I don't think I've written that one yet, right? So I need to go and we'll go up to right by where parse update is. Yeah, I'll just use this as a starting point. Not that that's really helping me that much. So this guy will return a while statement, going to be called parse while. It's going to take in a test expression. And it's going to also take in a execute statement. And we're going to be building a while statement here. This will be a new while statement that takes in our test expression. And it takes in our execute statement. That's what a while statement expects. And then I'll just return that guy. That's what parse while ultimately does. So now
So
I'll
for
go
the
back.
parameters, so in test expression and execute statement, so those two has to be the same as what we create in the update statement, or it's not?
Well, what are we doing here? We're building a while statement. We're building an instance of the while statement object. So what I pass this guy here has to be whatever this guy's constructor is expecting. So if I go into while statement, this guy's constructor is expecting an expression and a statement.
But we put the underscore here between.
Well, yeah, these are my variable names. These are the parameter names.
So it has to be the same.
Uh,
Exactly. Oh,
no,
that is what my
the
question
type,
is.
the type has to be the same. It has to take an expression. I have been bouncing back and forth between underscores and camel case, but yeah, I mean, this is just the name of the parameter. Whatever we name it here is how it gets used down here. All that we need to do is make sure we pass in something that's an expression and something that's a statement. This is the type, this is the parameter name. This is the type, this is the parameter name.
So
And this,
the type has to be the same, not the parameter name.
correct. Type has to be the same, not the parameter name.
I think he is asking if the name is different, but actually the content is the same. When you pass it from the pass expression to the while state update while statement, it is using a different name in verbally, but actually
Different
same
variable
in
name here.
Yeah, I
Yeah,
guess he's confusing the
This guy could be called LOL for all
Yeah.
I care. You just have to then use it as LOL down here. These are just parameter names for functions. So like, you know, basic, you know, this is nothing special to language theory. This is just programming. You know, a function takes in types and then we give them parameter names. And those parameter names should help us know what kind of thing we're passing to it. Like what expression, well, specifically, it's going to be a test expression. So I'm going to name this guy test expression. But however I name him here is how he has to be called down here. But the thing you pass into this doesn't have to match this name. It just has to be this type. So I think what he asked was, I think I answered, right?
Yeah, so when we create the instance like object of the while statement, it has to be the same type, not the same name of the variable.
Correct. And that's true for any programming language creating any kind of object. That's not a language theory thing. That's a how programming works thing.
Okay.
When something has a constructor that takes in two parameters, you don't match the parameter names, you match the types. It's what you have to pass it. All right, so that is our while statement. So this constructor takes that, so I need to go back to parser. Here's my parser, and we're in parse statement. All right, so parse statement, if I'm looking at a while, I get my pieces, I call expression. The test expression is going to be whatever parse expression returns for that. My execute statement is going to be whatever parse statement returns for this. And I go into parse statement. Oh, I'm already in parse statement, so it's going to be an update statement. So in any case, I have these two guys, and then I want to go ahead and I want to return parser dot parse while, and I'll pass him my test expression, and I'll pass him my execute. Actually, I'm passing him my test expression, and I'm passing him my execute statement. And this is really what you were asking about, is I happen to name my variables differently here than I did in the other. Actually, in this case, I named them the same. So he's expecting a test expression, I passed him a test expression. He's expecting an execute statement, I passed him an execute statement. But what was important is I passed him an expression, and then I passed him a statement. This guy must be an expression, this guy must be a statement. All right, so that's what I'm going to return from my parser for my while. So we can go ahead and test this on the parser side. Just check my input spider, while test created, blah, blah, blah. Should be fine. Show me where that is. So this is in parse statement 277. I'm looking at an update. We didn't really test our update on a let's actually test our update on this. Okay, that looks like it's okay. All right, so this guy is bombing on 269 is parse statement for my execute statement. And this is inside of my while. So let's just go ahead and give myself a breakpoint right here. And I'll get to this so we can look at what execute string looks like and see if that guy looks funny to us. It's just from old breakpoints.
It seems like you haven't built it because you already commented out. It shouldn't go there.
Right, it was because it was stuck at that other breakpoint. But you're right. It seemed weird. All right, so let's see what my execute statement looks like here. Execute statement is update E equals. There'd be more to it than that. Update E equals. My execute statement seems a bit short. So my test looks good, but my execute.
Because the do math line 265 temp split 2 split do math has do, so
Oh, yeah. So really what I need to do is I need to, what do I need to do?
either you could do the split by do space.
Yeah, do space will make more sense. That'll actually, I mean, this get a little ghetto, I guess, but that will. Floating media control. Let me just get back to my error place. Well, actually, I don't need to get my error place. I just need to get back where I was here. So I'm going to split it on do space here because do math has it. Is it a do dash math, something like that? So it's getting the do part. So if I do space, that'll be fine, but my trim will still work. So I won't have to change it in a different place. I stopped my debugger. I'm running it normally. Okay, so there's my while test expression, resolve expression, greater than e greater than some expression int literal 0. All right, so that looks like it's what it's supposed to be for parsing my while statement. So now we'll go back to here. Well, actually, now we're going to switch over to the interpreter side for our parse. So in our interpreter, I'm going to go into my Spider interpreter. We'll go to interpret statement. All right, so now we have another kind of statement. Well, here, I'll just steal. So else if I'm looking at a while statement, I need to now teach myself how to interpret a while statement. I'll pass it my while statement here. All right, so I'll steal this guy here. We'll go to interpret update statement. We'll just do it up by that. A private static void interpret while statement. This guy will take in a while statement, WS as a parameter. Okay, and ultimately what we need to do is we need to get the pieces out of the while statement. So we'll go ahead and do that. So the while statement is going to have our test expression, TE. This will be get test expression returns a normal expression. So I'm going to go ahead and typecast this guy to test expression now, because he has to be a test expression. That's the kind of animal he must be. Otherwise, I have a syntax error. All right. Now, we could, if we wanted to put error checking in here or something like that, we could ask whether this guy was an instance of, so we can say something like, if ws.get test expression is instance of test expression, then do this stuff. Else we could throw a new runtime error while loops require a test expression, something like that. Oh, not runtime error, runtime exception. And this is just a little error checking. We know that if you're going to write an accurate while loop, and you didn't have to do this in the homework, because we're focusing on the language aspect of this. So we know that if you're going to write a proper while loop, the expression part of it has to be a test expression. That's the kind of animal it must be. It can't just be any old expression. All right, so this is, we'll call this appropriate for a real interpreter, maybe a little overkill for our homework assignment, something like that. All right, so we have our test expression now. Now we're also going to go ahead and get our execute statement. That's going to be any kind of statement. Okay, and that's going to be ws.get statement to execute. Okay, so we have our two pieces now for interpret while statement. So now what do we want to do? We want to keep interpreting this statement over and over and over again, as long as this guy keeps boiling down to true. Okay. Now, if I remember correctly, let me look at interpret test expression here. This guy gives us an int of 0 or 1. So 1 is true, 0 is false. And I think I mentioned that most programming language, because you can do, this comes from the C programming language, you can actually do math with Booleans, which doesn't necessarily make tons of sense. But since they used to be represented as numeric literals, you could, the definition is 0 is false, anything other than 0 is true. That's the typical way it works. We've done it as zeros and ones. All right, so when we call our interpret test expression, as long as this guy keeps giving us something that's not a 0, okay, or he gives us a 1, you can decide which of those makes more sense, you know, to you. I'm going to write it the not a 0 thing because that's more appropriate to the history of languages. But for us, we're always returning a 1 or a 0, so you can ask either one. Okay, so as long as interpret test expression continues to give us a true, continues to give us a 1, we'll go ahead and interpret our statement to execute again. All right, so we'll go ahead and we're going to call spider interpreter dot interpret test expression TE, and we'll say while this guy gives us a value that is not equal to 0. Then what do we want to do? We want to go ahead and interpret the statement. We don't know what kind of statement it is, so we just call interpret statement and we pass it statement. Now, this guy potentially, though, will update our environment or something like that. In this case, it's going to be an update statement, right? So that will update our environment, and which should then give us a chance of having this guy fail the next time. Now, depends where we started it at. Like in our current example, it starts at a 2. So it'll become a 2, then a 1, then a 0, then it'll stop. Because we're asking whether it's greater than 0. All right, so keep interpreting the same statement over and over and over again, as long as this guy gives us something that's not a 0. That's what interpret while statement does. So I'll go ahead and call interpret. Go down to interpret statement. We have our, if we're looking at a while statement, what do? We call interpret while statement on that while statement, and it's going to go do what it was already doing. So right now we're going to say, we know that E came down to a 2 in this guy. So now we're going to say while E is greater than 0, so while 2 is greater than 0, do what? Update E to be whatever E currently is, which is 2 minus 1, which is 1. So it's going to, we're going to update E once there to make it from a 2 to a 1. Then is 1 greater than 0? Yes, we're going to update E again to make it from a 1 to a 0. Is 0 greater than no? No, it's not. So we're going to see 2 updates to our I must still be in the mode for, oh, hold on, sorry. I have to uncomment these guys. So we updated E to be 1, updated E to be 0, and then that guy finished. All right, so our while loop seemed to do what it is supposed to do right now. All right, questions about that? And if we wanted to really test this hard, we can do kind of like a update E to be equal to 20, something like that. So now we'll see many more updates to E in there. So notice that E went from a 20 all the way down to a 0. That's how many times we got into that loop. All right, so questions about the while statement.
I got many errors when I did this while program, while statement program.
Okay, well, I mean, that's not really a question. That's more of a statement that it didn't go as well as you would have hoped. Type situation. So I guess compare yours to what I have here. I'll go ahead and push this just so I don't forget. So now updated for while statements. I'm going to say for simple while statements. Well, actually, no, it's updated. It's already updated for a while statement. Just the while statement only supports a single statement being inside of it. And right now, the only statement that makes sense is the test statement. If we create new statements that make sense, then the while statement will still work. We don't, so it really is updated for a while statement. This was homework number 9. Okay, so now what would be really nice is for us to be able to do some additional things inside of our while loop, rather than just update the variable in our environment. You know, that's kind of giving us our leverage for our the test statement, the test expression portion of our loop, but we're not able to really do something multiple times. So one piece that we're currently missing from our language is we're missing the idea of doing a printing something to the screen. Right now, all of our stuff shows like a lot of hidden stuff, things that are happening behind the scenes. Okay, so we're going to go ahead and we're going to add some print. We're going to add a print statement. So it's going to be print, and this guy will be sum. Now, what kinds of things have answers? Statements do. Expressions are part of. Let me actually think about that. Print, result expression, do math expression, test expression. I think we actually want print to work on expressions, because statements, we wouldn't print a remember, we wouldn't print the result of a question, we wouldn't print the result of an update. So we're going to print some kind of expression. That's going to be a print statement. It's printing some kind of expression. So this is going to give us the ability to just say, hey, what's the value of something in our environment? Right now, we're seeing those values because we're displaying our variable environment, and we're also showing all of those You know, inside here, we're showing, hey, here's this hidden stuff that happens. So we're getting some feedback where really, if you were running a real Java program, you wouldn't see any of this stuff, right? You know, this is just for us developers' eyes that yes, something really did happen behind the scenes. It's not going to be noticeable because we have no way of showing stuff to the user right now, but now we're going to show some stuff to the user. All right, so this is our variable environment. Again, that's something we would only look at through like the debugger or something like that. Otherwise, we kind of remember what's in there, but we're giving ourselves this evidence because we don't have the ability yet in our language to display a value. We can't say print the current value of E. So I can see it. Our way of seeing it right now is either looking at it in here, or we can look at the various non-output things that are happening inside of our code. All right, so we're going to go ahead and we're going to give ourselves the ability to finally print something out to the user. We can see something that comes out. Okay, so what we're going to do is we're going to start with our parser as usual. We're actually going to go ahead and give ourselves a print statement first. So inside parser, I'm going to create a new class print statement. And a print statement only takes in an expression. This is the expression to print. All right, and it's called the print statement. So we'll update our constructor name to be print statement. We'll throw that thing there. And we'll say this dot expression to print for two string here. We'll just call our expression to print. I'll go ahead and dump these guys. We'll generate our getters and setters again under source. Generate getters and setters. And we're just going to give ourselves a getter for this. I never like doing setters until the way I code typically is I kind of let it organically grow. Now, we might make an argument, this is related to what I said a little bit earlier, that for something this size, it's kind of organically growing because it's being taught in the context of a class. So, you know, each week we kind of have like, here's the next feature, then the next feature, and the next feature, where realistically, if we were doing this in industry, actually writing a programming language, we would probably sit down and decide on the features of our language, or at least version 1 of our language, before we wrote any code. That way we can take different and really plan it out ahead of time. That way we can make sure that, you know, things were kind of compatible with each other as we went along, rather than right now, the way we're having to do it is we're kind of reacting like, oh, I have an extra space here because of what I did back there, so I have to handle it here. And so what we're doing right now is a little janky. It's probably not the way you would really want to go about it for a programming language you were really releasing to the public. But because we're doing this in an educational setting where each week we're just kind of tacking something on, and we have to kind of adjust based on what we have time for and what's the appropriate complexity for the next assignment, that kind of thing, we kind of have to handle it this way. Is what it is. But so typically what I do is I rarely will have a problem with giving myself the ability to read a value. If I think somebody might need my expression to print externally, I have no problem giving them read-only access. But I usually won't do a set until I know I need it. So I usually keep it locked down and only add it later, as opposed to you might feel like, well, you know, I'll just go ahead and hit this checkbox. It'll just give me both. That might be easy to do, but then all of a sudden you've exposed all sorts of aspects of your code that you might not want. I like the kind of the cadence of saying, keep things as locked down as possible and only unlock them as you need them. I believe that's the better way of going about this. That way we kind of stumble upon like, oh, I can't get to that value. I need, or I can't update that value. I need to go ahead and add the ability to update that value now. And then you go back into your object, you extend it, but then you're doing it for a reason. Okay, so for print statement, I have my expression that I'm going to print. That guy's ready to go for me. So this is my print statement. So a print statement is a statement. It only holds one piece of information. That's the expression it's meant to print. Now that expression could be complexy as we add more and more expressions to our language, but it's just an expression. So we build it with a single expression. We set that expression. We have our toString and stuff, and then we have the ability to get the expression. So our print statement is a fairly simple little thing here. So now we'll go into our parser. Same thing we've been doing, same exact cadence. Okay, we're gonna go ahead and
I have a question.
go ahead.
The thing is, like, the print statement comprises with a string followed by the expression, right, in the other languages. So can we take string as well as the expression? Just rather only printing the expression, you can add the string to it.
Well, you could, but now you're adding a new kind of expression. You're adding a string literal expression. What you're saying is you want to do something like this. You want to say print hello, right?
Yeah.
That's fine. We can add that to the language, but right now our language doesn't know how to handle this. Because right now our language only knows about numbers.
Oh, okay.
Yeah. So I mean, what you're saying is completely reasonable. In fact, it's probably like the next expression type we want to add. So you're absolutely right. It would be nice to be able to write a hello world program in our language. But right now we can only write the print zero program language or something like that, because everything in our language right now is a numeric. So yeah, certainly probably the next expression type we'd want to add is the ability to deal with a string literal or char literal. Those kind of things is instead of just numeric literals like we have right now. That makes sense? All right, so parse statement. We'll just do it up here. Else if the parse at bucket 0 dot equals print. If I'm looking at something that looks like print, no problem. I need to print the result of my expression. So I'll go ahead and do something pretty similar to what I've been doing. Substring print dot length. Well, I wrote that pretty janky. All right, so that'll get me everything after print, which effectively is my expression, right? So I'll go ahead and get the expression. This is the expression to print. this guy will be equal to parser dot parse expression, and the expression I'll give him is temp. That's string. Okay, because this is the actual expression, the stuff that comes after print. All right, and then that's my that's my expression. So now I'm going to return parser dot parse. Didn't I just write parse print? Well, maybe I wrote it in my head. I didn't actually write it out here. And I'll pass it the expression I'm going to print. All right, so I need to go and write parse print now, which is going to be simple. I'll put it up by parse update. So static, he'll return a print statement. This guy is called parse print. It'll take an expression. This is the expression to print as a parameter. And we'll go ahead and create a print statement. PS is equal to a new print statement, passing it the expression to print. And then we'll return that print statement. So that's what parse print does. It takes the single expression that we want to print, builds a print statement object out of it, and returns that object for me. So nothing overly exciting. So now inside of parse statement, here's my print. I go ahead and I'll return the print statement object, one of my statement objects that comes from calling parse print on this. All right, we'll go ahead and test this. So again, we'll test just our parser. Make sure it's coming out of there nicely. We'll go into our input and I'll go ahead and just do a print E like that for this one. So the last thing we should see is we should see a print statement that is resolving AE. I wonder why that keeps happening. I keep getting back into the debug mode of my, whatever. Doesn't matter. Clicking a couple of things is making it go away, so that's fine. It's probably I just need to restart Eclipse. There might even be an Eclipse update or something. So there's my print statement, resolve expression E. Okay, that all looks legit. So now we'll jump over to the parser, or the interpreter side of things. Just so I don't forget, I'll go ahead and recomment this, uncomment this. We'll go into our interpreter. All right, and we'll go ahead and add, right now we are inside of interpret statement. So else if S is an instance of a print statement, if it's one of those guys, what will I do? I'll call spider interpreter. Let's steal the whole line. I'll call spider interpreter and we'll call this interpret print statement. And I'll go ahead and copy that. And this is going to take in a print statement version of S. So we'll go down and get that guy. So we'll put it like after interpret update. Okay. So we'll have a private static void interpret print statement. This guy will take in a print statement as a parameter. And we want to interpret that guy. Now notice, instead of us doing something that's going to be hidden, we're going to actually have a real thing. Maybe we'll even put some asterisks before it, so kind of flag visually for us this is something that's actually going to be outputted to the screen, because maybe later on we'll hide all the hidden stuff, like we'll say, you know, debug code off or something like that. All right, so this is an interpret print statement. And then what will we do on our interpret print statement? Well, we have our expression. So this is the expression to print, and this will be equal to ps dot expression, get expression to print. All right, that's the guy we're going to mess with. So then we'll go ahead and say int answer is equal to, we're going to get the value of that expression. What expression? The expression we want to print. All right, then we're going to add something to our output. Well, I'll just steal the first part of this. And we're going to add, I'm going to put 5 asterisks, let's say. And then we'll say, well, let's actually just print out the value instead of doing print or something like that. So we'll just concatenate onto that answer like that. And then that is what should show up on our screen when we interpret our print statement. And it did work. I think it didn't, somewhere it's stuck that I'm like going between my interpreter and other stuff. So it's printing out the current value of E, which is 0 because we had counted down. If I go into here and I say, well, let's just print out A should still be 5, I believe. There's my A is 5. Okay, so now we have the ability to print something to the screen. All right, so questions about that? I'm going to still leave our hidden stuff in there just so we can see all the stuff that is happening behind the scenes. Because ultimately, when like, you know, if we're in the released version of our program, if I look at this code, the only thing I should actually see on the screen is this one line. All this other stuff is behind the scenes logic. But what would be nice is if I could update E, but also print E inside here to get multiple print statements. Let me go ahead and we'll say updated to support print statement. All right, so now let's go to our keynote. And let's talk about block statements. So typically what we've seen in languages is we've seen like an opening and closing curly brace and then stuff indented inside of it. Statement, dot, 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 that kind of stuff. Okay, so we've thought of these guys as block expressions rather than block statements. Let's call them block expressions. Let me think about that for a second. For our language, we need to call them block statements because the loop executes a single statement. So that's fine. This will be a block statement like I've written in here. All right, so that's going to be a block statement. So really, when we say a block statement like this, what we're really doing is we're saying this guy lives like that. I can create just a statement like this that has a bunch of things inside of each of them. And he actually can live on his own. And let me tell you what I mean by that. If I come out here to driver, is that allowed? Can I create a block statement? And here I'll even throw the extra. Oh, that's funny. Eclipse prevents me from doing it. Oh, there we go. Okay, this looks funky, correct? But notice it still works. Okay, we're not used to doing this. We're not used to saying, oh, well, I'm just going to throw a block statement here in the middle. Well, the reality is we are. That block statement we're doing is right here. Okay, notice that we were allowed to put the semicolon there at the end. And I just like I can do this, I can put a semicolon at the end there. Still works. So even though these are things we typically don't do, this is kind of a syntactic sugar thing that says, oh, well, with opening and closing curly braces, we can match the closing curly brace, so I don't actually need the semicolon to end the statement. For us, we're going to use the semicolon because that's going to tell us when the statement actually completes. Okay. But the point is that what is a block statement? A block statement is a collection of statements embedded within a single statement. This can now be used as the single statement for a if or loop or function. Does that make sense? Now, perhaps in our language, so let's just go ahead and write out the homework. And this is due, what is it on those? Second. So homework due 12/2. Create a block statement in our language and test it with while loops. Perhaps, and the way I'm going to write this is instead of having an opening curly brace and a closing curly brace, I'm going to have a block statement be a begin to an end. Okay, so we're going to say begin statement, end, like this. Okay, so that's going to be my begin to my end, and it's going to execute some number of statements in there. I could choose to just put one statement in there if I want, but I should be able to put multiple statements. So for instance, in our code up here, maybe we want to do something like while test e greater than 0, do begin print e, comma, update e is equal to that, end. Something like that. Where each time through, so e start off at 20, it'll print 20, 20 will become 19, spin back around, test again, print 19, 19 becomes 18, so on and so forth. But now I'm actually able to do more than one thing inside of one of my single, inside of my while, because I'm doing it inside of a begin end statement. Does that make sense? What I'm asking you to do? All right, so questions about the homework. And this is due on Wednesday. Got nothing? Okay. Well, so then I will see everybody at 10 a.m. on Wednesday online again. And we'll go ahead.
Have you put that on content?
Oh, thank you. I'll put it on Blackboard. This is homework 10. Just leave it like that. Submit a GitHub link as well as a self-eval.
Can you add the example too?
Well, it should already be in the code. You should already have this. We'll just say this example. Like that. Oh, wait a minute. So we do on the 2nd by 10 a.m. Now, one thing I would say to do is when you're doing the self-evaluation, give me some more information about what is where your struggles were. Because what I'm basically getting from several people is, the same thing copied from the previous week saying, like, oh, everything worked perfectly. I didn't have any problems. And when I go to run the thing, it doesn't even come close to running. So, give me some feedback so I can zero in on, where you really struggled in the assignment. I can look at the things you tried. Make sense? I mean, if you're telling me it works perfectly and then, it has like 20 errors, something's not lining up there. All right, any other questions?
You updated the GitHub, right?
Yeah, the GitHub is updated. The only thing it's not updated for is my most recent while loop I wrote here. So what you have on GitHub right now functions. You should be able to hit play on it and it runs.
Okay.
Sound good? All right, I will see everybody on Wednesday.
Thank you.
Later.